I was one of a number of people who really independently came up with ideas of artificial intelligence. I would guess that there were at least 6 and maybe 10. My ideas of artificial intelligence came when I attended a conference, a symposium on cerebral mechanisms in behavior. And one of the things that happened at that conference was a comparison of the brain and computers. Now, it occurred to me that, well, one wanted to program computers to behave intelligently. And I imagined that people had talked about that at the conference. But when many years later, I had to give an autobiographical lecture, I went back and read the proceedings of the conference, and I discovered that no one had talked about actually using computers to behave intelligently. My idea was to have a summer study analogous to the summer studies that had been held about some defense problems. So it seemed to me that if 10 people got together and spent the summer, that substantial progress might be made. And so I got 3 other people, Nathaniel Rochester from IBM and Claude Shannon and Marvin Minsky, to join me in submitting a proposal to the Rockefeller Foundation to support a study at Dartmouth for the summer. And for the purpose that the people who came would know what the subject was about. It wasn't automata in general, but was aimed at artificial intelligence. So I called it artificial intelligence. Now, certain things didn't happen as planned. The Rockefeller Foundation gave us only half as much money as we asked for, and most of the people who came could only come for a short time. I thought we would make substantial progress towards human-level artificial intelligence that summer, and we didn't. And human-level artificial intelligence has turned out to be a very difficult scientific problem, and it isn't solved yet. But then it was 100 years from Mendel's work to the deciphering of the genetic code. So people shouldn't be discouraged if it takes a long time. Well, I was interested, I think, from the beginning in making machines that could perform intellectual tasks and would behave intelligently. So I had a mathematical model of a machine connected to an environment. It was a bad model, and John von Neumann encouraged me in it, but I eventually decided it was a bad idea in that form. They never published it. A lot of the people who were interested in artificial intelligence did not know about programming computers. They thought more directly in terms of electronics. In 1952, I spent the summer at Bell Telephone Laboratories and suggested to Shannon that we jointly edit a collection of essays that we would get from various people. And my goal was that the collection of essays would be related to what was later called artificial intelligence. Shannon agreed with that, but he wanted a more modest title, so the book was called Automata Studies, and it was finally appeared in 1956, so 4 years later after we started the project. I had one article in it, inversion of functions defined by Turing machines, which was definitely an AI-oriented article, and several of the articles were AI-oriented. But to my disappointment, the majority of articles were not. So that in 1955, when I wanted to propose the Dartmouth summer project, I wanted to nail the flag to the mast, and for the purpose that the people who came would know what the subject was about. It wasn't automata in general, but was aimed at artificial intelligence, so I called it artificial intelligence. My idea was that to have a summer study analogous to the summer studies that had been held about some defense problems. So it seemed to me that if 10 people got together and spent the summer, that substantial progress might be made. And so I got 3 other people, Nathaniel Rochester from IBM and Claude Shannon and Marvin Minsky, to join me in submitting a proposal to the Rockefeller Foundation to support a study at Stanford, to support a study at Dartmouth for the summer. Now, certain things didn't happen as planned. The Rockefeller Foundation gave us only half as much money as we asked for, and most of the people who came could only come for a short time. The results were not in accordance with my rather grandiose hopes. Okay, well, artificial intelligence is making machines that can solve problems and can act intelligently in environments and achieve goals in environments. Now, what the ultimate goal is to get human-level artificial intelligence so that it should be able to match human performance in these areas. The area in which we are still most lacking is in the area of common sense knowledge and reasoning. And so that's where, to get human level common sense knowledge and reasoning is a major goal. To take an example, this example was proposed by Douglas Lennott, and I agree with it. It's still not possible for machines to learn, say, science from reading things that are on the internet. because they don't have enough understanding to be able to understand a textbook of science or mathematics or even a novel. And so Leonard pointed out that once computers can learn from the internet, then they really ought to advance very rapidly, but they can't yet. I had the impression that maybe I had heard the term artificial intelligence before, but I didn't know where. And just recently, there was a letter in New Scientist in which Philip Woodward claimed that he thought of the term artificial intelligence and that I got it from him. And that might be true, but if so, he's got the year wrong, because he said that he proposed it in '56, whereas I used the term in August '55 in writing the proposal. But he could be mistaken about what year he was at Harvard. So if he was at Harvard in '55, then I might very well have heard the term from him. Well, I don't remember as much about the atmosphere at the conference as I probably should, because being rather self-centered, I remembered mostly my own ideas, and I didn't remember them too well because they got replaced by better ideas 2 years later. But the outstanding people there were Newell and Simon and Marvin Minsky. And there was this very interesting chess program being proposed by Alex Bernstein of IBM. Raymond Solomonoff was proposing ideas that later got further developed by the Soviet mathematician Kolmogorov of computational complexity. So I didn't understand Solomonoff at the time, but his ideas played a role in the future. The most impressive presentations at Dartmouth were by Newell and Simon. They presented two things. The first was their language IPL, which used list structures to represent symbolic information. The second was their program, The Logic Theorist, which proved theorems from the first chapter of the Whitehead and Russell book, Principia Mathematica. Their program was based on observations of students proving these theorems. So that was quite impressive work. From my own point of view, what I most got out of it was the idea of using list structures. A list structure is a configuration of the memory of a computer, and where each item, which may be a half word in many machines, has two parts. And one part is a data item, and the other is the address of the next word in the structure. So one can follow the sequence of items by successively following the second halves of the words. And a key point is that the symbolic expressions don't have to be of a predetermined length. They can just go on until some signal says that's the end of it. LISP structures can be used to represent any kind of symbolic information, like algebraic formulas or logical formulas. This was a tool. Now, mathematical logic was invented over a period of, one would have to say, 300 years, successively by Leibniz and Boole and Frege. All three of these men wanted to be able to represent what we would call common sense knowledge in mathematical logic. In particular, Leibniz advanced the slogan that instead of just arguing, people would say, "Let us calculate," and would come to an agreement by calculation. Now, that goal in terms of logical languages that are applicable to human affairs has not been realized even to this day. What happened was that the logical languages did prove adequate for representing mathematics. And some of the mathematicians now think that that's all they're good for, but that's a mistake. The result was a language developed at IBM by Herbert Gelernter and his group that was called the Fortran Lisp processing language. And they did a program to prove theorems in plane geometry based on an idea of Marvin Minsky's, that you should only try to prove sentences that were true in a diagram. So that work started in September of '56, that is after the Dartmouth conference, and the program was working in 1959. From the point of view of human-level artificial intelligence, just having a rather specialized geometry theorem prover was a modest achievement. Now, compared to some things that have been done since, it still looks pretty good. In the summer of 1958, towards the end of the summer, I was at IBM, and I wanted to write a program for doing symbolic differentiation in the way in which one is taught to do it in a calculus course. And when I wrote this program, I saw that FLPL, the Fortran Lisp processing language, was not suitable. It would have been quite inelegant. So I needed recursion, and I needed to get rid of explicit erasure of structures. I didn't want to have things erased, the user have to erase things. When I came back to MIT in the fall of '58, we had started the MIT Artificial Intelligence Project. So we started work on a compiler for LISP and wrote programs in machine language which were hand translations of LISP programs. And then I wrote a LISP program called eval, which was a universal function for LISP, analogous to what Turing had done in 1936 with his universal Turing machine. A programmer, Steve Russell, said, well, I'll hand compile eval and it will be an interpreter for LISP. And he did that, and that's the way the first LISP got started, because the compiler took quite a long time. One of the other things that I don't remember was the financial details. Namely, were there people who we would have liked to have come but couldn't come because we didn't have enough money to pay their travel and living expenses? $7,500 wasn't a lot of money. So if we'd had twice that, we might have had a couple more Englishmen, or a couple more people from the West Coast. But it seems to me that the major people who spent only a short time did so for other reasons than a lack of money. I thought we would make substantial progress towards human-level artificial intelligence that summer, and we didn't, and human-level artificial intelligence has turned out to be a very difficult scientific problem, and it isn't solved yet. But then it was 100 years from Mendel's work to the deciphering of the genetic code. So people shouldn't be discouraged if it takes a long time. IBM has had its ups and downs with regard to artificial intelligence. So up to 1959, that was fine. Then in 1959, they thought their customers would be frightened by even the use of the term computer, so they called them data processing machines. But IBM then later came to use the term artificial intelligence and brag about what they had done in the field, even though they had killed their best projects in 1959. So I can't keep track of the ups and downs, but I think within IBM, the term artificial intelligence is okay today. I came to a definite conclusion about what the key would be for me 2 years after the conference in 1958, and that was the representation of common sense information in languages of mathematical logic and using programs for proving theorems in mathematical logic as a tool. But that was later. Robotics can be done in a way which does not involve any artificial intelligence at all. In particular, the robots that are used in factories often go through a fixed pre-planned sequence of actions, and their action does not depend on sensing anything. Now they can get more sophisticated, and one can have robots that can walk now, and in which their actions are dependent on the inputs. Now it seems to me that you can use artificial intelligence to control robots, but that's by no means the dominant application of artificial intelligence today. So I'm easy with robotics. Yes, I know about the soccer-playing robots. I'm most familiar with the ones with the project at the University of Technology at Sydney, led by Marianne Williams. And the robots themselves are so limited in their capabilities that it's very difficult to apply a lot of intelligence to controlling them. But the competitions have been gradually getting more sophisticated. One of the things is that each robot has its own computer, and their communication is extremely limited, and so there's nothing like the coordination that you would have with the real soccer players. There are various people who criticize artificial intelligence. One might suppose that their basic motivations are almost religious, but I have this characterization that Hubert Dreyfus at Berkeley considers artificial intelligence to be impossible. He first said that a computer could not beat him at chess, and well, in the early 60s, a computer did beat him at chess because he's a really very bad chess player. John Searle, who's a philosopher at Berkeley, said that the concept of artificial intelligence was incoherent because they weren't biological systems. Intelligence was a characteristic of biological systems. And Joseph Weizenbaum said, well, maybe AI was possible, but if so, it was immoral because it wouldn't enable the government to control us all. So those are three of, but nevertheless, none of these attacks have really amounted to much in terms of their effect on the ability of people to do AI research. The attacks on genetic engineering and the attacks on, say, nuclear energy have done far more damage to human welfare than these rather minor attacks on artificial intelligence. Now, I should admit to an exception with regard to the attacks on artificial intelligence not doing any harm. That is, the attacks on artificial intelligence around 1980 in Britain by Sir James Lighthill did do quite a bit of harm and did cause certain projects not to be funded. The advances in artificial intelligence, or the things that have been done in artificial intelligence, have moved in many directions, and none of them are close to human-level intelligence or are sufficiently general so that they could be considered to be candidates. They are all somewhat specialized. It's not so much that I advocate an immediate attack on general intelligence or human-level intelligence, but I think that research in artificial intelligence should be evaluated by the people who do it and by the referees that decide what papers to publish in terms of whether this moves in the subject in the direction of human-level intelligence. One of the bad things that happened recently, and has happened at Stanford, for example, is the attitude that a student should not do a purely theoretical thesis, that any thesis in AI should have as its capstone the implementation of some kind of program. And I think that attitude is mistaken. Most students still will do it, but nevertheless the prejudice that they absolutely must do it is mistaken. I can't guarantee that my way is the best way, and it certainly is not the way that a lot of people are following. But what I would suggest to the student is that he create or get hold of a really good theorem prover and problem solver, one that is not based on resolution. So this is a technical quarrel that I have with the way people do things. But anyway, what it basically says is that you need a new one that doesn't throw away information the way the current ones tend to do, that information. And then that he pursue also the formalization of more and more common sense knowledge and reasoning in mathematical logic, and then get his problem solver to solve problems based on common sense facts. The term artificial intelligence has stood up very well. Now, there are some Canadians that want to call it computational intelligence. And if we were starting all over again today, that might be a good idea. But it wouldn't have been a good idea in 1955 because a large part of the people who were interested in artificial intelligence were not yet convinced that programming computers was the way to achieve it.